The big question is, are they similar? Well, first we have to know what similar means in math, because it might mean something different than in English. Similar for the shape means the shape stays the same. If you have a triangle, it's going to stay a triangle. If you have a rectangle, it's going to stay a rectangle. And we had a homework question that looked like that, where one was like an octagon and one was a star. And they were not similar because they were different shapes. There we go. Okay, and what happens with the angles? The angles also stay the same. The side lengths, they do not stay the same. The side lengths get multiplied by the same number. They all get multiplied by the same number. That number is called the scale factor. Okay, and then the rule. The rule, if it's similar, is going to be scale factor times x, scale factor times y. Notice it's the same number in both in front of the x and the y. If you need to pause the video now to get those 4 things written down, please do. If you're all set, we're going to actually look at one and decide if rectangle ABCD is similar to rectangle UVWX. Okay, so let's check. Did the shape stay the same? Yes, they are both rectangles. Did the angles stay the same? Yes, they are all still 90-degree angles. Did the side lengths all get multiplied by the same number? Okay, so in order to tell that, we need to find corresponding side lengths. Which side length is corresponding to 8? Hopefully you said 16. Okay, let's check the scale factor on that one. What is our scale factor from 8 to 16? And remember, you can do original. Let me give you the original one. Original and new. And to find your scale factor, you would do new divided by original. And you guys do a nice job of that when it's a whole number. On the quiz, we struggled with what if it was a fraction? What if it's getting smaller? So that's what we need to work more on. All right, so what's that scale factor from 8 to 16? All right, so we should have the new is 16, and the original is 8, so our scale factor for that one is 2. Okay, and that's true for all of these sides, all the vertical sides, because we know that this is 8 also, and that this is 16 also. So I checked half of the sides. Let's check 12. Which side is corresponding to 12? Oh, the 24. Okay, and I'm going to make these ones too. All right, tell me what your scale factor is from 12 to 24. And we'll check and see if that's the same thing. All right, so our new is 24 this time, and our original is 12. 24 divided by 12, oh, that's also 2. So are these two going to be similar? Yes, they will be similar because the side lengths all get multiplied by the same number, called 2, called the scale factor. And what do you think our rule would be? Scale factor times x, scale factor times y. All right, so that was number 1. Let's check if number 2 is similar. All right, so are these both the same shape? Yes, they're both rectangles. Are these both all the same angles? Yes, they're all 90-degree angles. Do our side lengths all get multiplied by the same number? Okay, let's go from B to A this time so we can get a fractional side length. Which side length do you think corresponds with the smaller side length 3 in rectangle A? Oh, hopefully you notice that they turned A. It corresponds with 2. This is going to be our new this time, and this is going to be our original. And I'm specifically going from the larger one to the smaller one to practice. And this 4 goes with this 6. Okay. All right. New. Let's put scale factor first. Scale factor equals new divided by original. Okay. So our new this time is, figure out what the fraction would be. Okay, so you should get 2 over 3 for the blue ones. And then if you divide that, 2 divided by 3 gives you 0.6 repeating. And then let's see what happens with the other ones. The red ones. New is 4. Original is 6. 4 divided by 6. Oh, that also gives you 0.6 repeating. Oh, so are these similar? Yes, they have the same scale factor. Let's write it as a rule. All right, so our scale factor from B to A was 0.6 repeating times X and 0.6 repeating times Y. If it's a different number, that's when you have them not being similar. Number 3. And you can pause the video to finish number 2 if you need to. Number 3, are the 2 wumps similar? I'd like you to check the shapes, the angles, the side lengths on your own and say yes or no. Okay, so let's check the shapes. Do they look the same? Yes, he just looks larger. Let's check the angles. Okay, let's see. All right, if I drag this over, yep, that angle looks good. And I can see these are still 90 over here. Let's check the side lengths. And let's do an easy side length. Up here, I know that this is 1, 2, 3, 4 long. 1, 2, 3, 4, 5, 6, 7, 8 long. What's my scale factor from 4 to 8? This is my new, because that's where the arrow lands. This is my original. New divided by original. Okay, figure out what that scale factor is. If this is 8, and this is 4. 8 divided by 4, that scale factor is 2. Okay, let's see if it's 2 somewhere else. Let's check. Let's use a different color. Let's check his foot. Oh, his foot's only 1 long here, and it's 2 long there. All right, so let's do scale factor equals new divided by original. Oh, it was 2 for the new, and I started out as 1. 2 divided by 1 still gives me 2. All right, so my scale factor is 2 for everything. It's getting double the size. He got twice as wide, and he got twice as tall. So your rule is 2x, 2y. And that is the end of the first side.